Okay, welcome back. Moving on. This time around, today we will talk about the redirection. In this case, we talk about the input redirection and output redirections. We talk about standard in, standard out, and standard errors. Just like other programming languages where you have to deal with inputs, you have to deal with output and errors. Bash 2, we have ways of handling that. So in this case, we start with standard in. Standard in is anytime you have to go to the shell and you have to type something in the shell prompt or the command prompt, then of course you're actually on the standard in, and this is what you have to do a lot. So for instance, if I type echo my name, you can notice here that this was actually me typing and then being received in standard in, and this output here was actually an output from the standard out or standard output file. So this is cool, and anytime I type maybe echo my name, you notice the error that comes out. So the error here is being generated from the standard errors, and this is being sent back to the standard out to display so that we can see that there was a problem. This is cool and all, but what is interesting is each of this standard in, standard out, and standard error actually have what's called a file descriptor. Everything in Linux, actually in Unix, actually have a file descriptor. So if you type something in the input, you actually type in, and that thing has a file descriptor. So the default file descriptor for the standard input is the file descriptor 0. So anytime you want to access that in programmatically in terms of writing your shell script, or you just want to understand how the operating system allocates the file description or descriptors to the system, then of course the file descriptor number is 0 for standard input or standard in. Now for standard output, the file descriptor is 1. Okay, so and for standard error, the file descriptor is 2. So I'll show you how to access one or two of the file descriptors so that we can play around with the output, but most of the time I'll basically be talking about the standard error, because standard errors work is more useful because we don't want to show people more errors on the screen. Rather redirect it to a log file or a separate file that allows us to deal with the error messages. So this is just like you running an application and then put it in development mode, and after that you now put it in production where you don't want people to see the errors that comes out of your application. So having said that, let's basically understand that the redirection is nothing more than using the greater than or the less than symbol. The less than symbol actually indicates redirection to an input, so an input redirection, if you will. And for instance, let me just try to run the command we did earlier, but before that there's something that's been bothering me in this case, which we omitted. If you notice, there's no space between these two, which makes my command stuck to the command prompt. So I'm just going to export the ps1 variable again, and this time around I'll just quickly go through it. So I put the U for the username, I put the @sign, and then I put the H for the host name, and then I put the W for the working directory. Let's go ahead and throw the time then, since we've done that. So here I'm just going to go ahead and put the $sign, then a space. So this time around you see that there's a space between these two, so nothing changed, it's just the space I added. So that if I clear the screen right now and I run the cut command on C1 and 2, and then what I have to do is now do the input redirection. So I'm going to redirect to this command, an input from my previous command, right, or command I'll run after. So the command I'm going to run after is just the cat or the tail, like we did before on file 1.txt. Alright, so it's not actually taking the command like this, which is okay, which is cool. So I just wanted to show you how the redirection might work with the commands. In this case apparently it's not, so let me try cat, and this is also not valid. Alright, so let's see. Alright, sorry for that. So I was not supposed to use any of the commands, it was just a file name. So what happens is here we take the file and we feed it into the cut command, and what the cut command does is it checks the content of the file and run the cut into it. So ignore these two errors, I was just trying to use the command, and this is the proper way of doing it. So you can see here, this is what we refer to as input redirection. So what happens is we redirected a file called file1.txt as the input of command cut-c1 to 2. Alright, so that's a easier way of understanding that. Now the next one here is the standard out. Obviously standard out, if you want to redirect standard out, is as easy as you writing, for instance, let's say we just want to run the echo, let's say my name. I want to echo it into a new file, so let's say file2.txt. Notice this time around I'm using the greater than symbol, and the greater than symbol means I'm redirecting out to a file called file2.txt. So nothing showed, so if I concatenate the file, you can see here I have my name, so my name was stored in the file file2.txt. Now with output redirection you also have an additional capability. So in this case, if I run the single one here and I change my name to let's say your name, and I press enter and I run the cat command again, now notice this time around it has removed what was there before and then put a new one. This is because I'm using the single output redirection character. So what happens now if I want to append to your name? I just want to add something there, so let's say our name, and then if I run this, obviously it's going to replace your name, right? But this is what I want to do. I want to add to your name our name, so I'll now put double greater than sign. So this is short for redirect out as well as append to the existing file. So if I press enter right now and I run the cat command, this time around you can see that apart from having your name, we've appended our name there. So obviously you have to pardon me for the hilarious names of things I've been using here, because your name, our name just sounds weird, but this is just to explain how this symbols work and how they get redirected to the output and the input, which is cool and all. So the next one is standard error, and standard error is nothing but some where we trap errors and then we display it to the users. So for instance, right now I want to redirect the output, right? So now that you know how to redirect output, let's redirect it to a new file. So we already, the next file we have that is empty in our list here is, I know we have file1, so if I cut file1 or file, there's nothing in it. So let's say we want to run a command that does not exist, so echo, let's say this is unintentional, but we want to trap all errors and put them in a file. So if I say echo my name and I redirect it to file.txt and I press enter, now there's a problem, right? Because this was supposed to take the output and then put it in the text file, as opposed to previously when we took the output and then put it in the file and then there was no output. So here the problem is standard error gets generated after standard out has after the file has been created using the redirection. So this is not good. So the only way to fix this kind of problems here is to access the standard out from using the file descriptor. And if you remember, I just mentioned that the standard error, the file descriptor for the standard error is the number 2. So how do we access it? Well, it's as easy as actually putting the number number and then the greater than sign. So this tells us that take all the error messages that are generated for this command or for the common commands and redirect to the file called text. So this time around, notice there was no error, even though we did the same mistake. But if I cut file.txt, now you can see that what was supposed to come to standard out was redirected to standard to the file.txt file. So here you can see the redirection has been you can see how the redirection works and how it's done. So hopefully this makes you understand standard error, standard output, and standard input. If you don't, please go over the video again and read on the course material I've given you. The next thing I want us to look at here is quoting, right? So if you notice, I was writing my name in quotes, double quotes. Well, we have two types of quotes. In most programming languages this is similar. You have the single quotes and the double quotes. Now the difference between the single quotes and the double quotes in this case is the single quotes will actually output everything you put between the single quotes as the literal that you've given it. So for instance, if I put my name is $John /n, for instance, is going to output exactly what you give it to it. So it's garbage in, garbage out, and that is usually referred to as full quoting, because you're actually quoting everything and you're not making it partial. So the next one, the other one is the double quotes. Now double quotes, in as much as they try to be like single quotes, here are usually referred to as partial quoting, and the reason is because single quotes or partial quoting, double quotes or partial quoting in this case, allows you to include variables or variable names, in this case dollars something, and it gets expanded when the system or the bash interpreter runs the lines in your script. So for instance, let me just give an example. Let's set a variable. Let's call the variable name, and I'm going to make it equal to, now this is not important, so let me just say 10. Let me just give it a name. So let's say num is 10. Alright, so I've created a variable called num and I've assigned 10 to it. So now I want to echo in single quotes the number is. Now you would expect us to use num, right, which is correct, and I put num. Now look at the problem. Now I said the number is then $num, but because we said single quotes, which is full quoting, we'll take everything in the single quotes and treat it as it is. You can see the output is exactly what we've given it here. Okay, so but now if I try to run this with double quotes and I press this with double quotes and I press enter, notice that double quotes understands that this is a variable, and then it takes the value that we created in the variable and then assigns it to that value. So the number is 10 here. So you can see the difference between the single quotes and double quotes in this case. This is something you should know. So the question about when to use single quotes versus double quotes is totally up to you. It depends on what you want to do. If you are not including any variable, or you don't want to expand any variable within your quotes, then you can go ahead and use single quotes. But if you're going to be having variables in between your double quotes or your quotes, then obviously you go ahead with the partial quoting, in this case double quotes. Alright, so that's hopefully about quoting and all the mystery behind quoting and quoting nuances. The next thing that we have to do now is now we've talked about a lot of all this concept and all that, but how do we actually go ahead and create a shell script? Remember, this is bash shell scripting. Okay, so we've talked about all the concepts and we've been using the command line for it. Yes, we are right, because the command line interpreter has bash in it, but we want to create a single file, in this case a shell script, that will contain all of our scripts, right? So all the commands we're going to be typing will be in the script. So for instance, let me clear the screen right now and let's create a new file. So I'm going to make a new directory. I'm going to call it let's create a new directory. Let's call it CMP319. Okay, make a directory. So hopefully you've seen me in the video make the mistake and you've been shouting, Mr. Murphy, what's wrong with you? Typing what's correct. Alright, so this is the correct one. So I go into CMP319 and this time around I'm just going to touch a new file. So I'm going to call it maybe script1.sh. Now notice a couple of stuff here. Why do I have to put .sh? Well, this is really not needed. Remember, bash or the Linux environment doesn't care if you have an extension or not. The file tries to pass the whole file as it is. But in this case, as a rule of thumb for best practices, it's always good you add something that tells the person looking at this file right now that this is supposed to contain a script. So we add the .sh here for shell script or shell. This is just a common practice. You can put anything you want. Alright, so I create the file and then I use my text editor nano to edit the file. Alright, now the way you write a shell script is basically you start with what's called a hashbang sign or a shebang. Basically it's this line right now, right here. So let me just type it. So you see some people use bash or sh. Anyone you put here is totally okay, it works. So this is the shebang or hashbang line, and if you notice it starts with the octothorpe symbol, and if you're wondering what an octothorpe is, this is the original name for what we always call the hash sign. Okay, so the hash sign here, the first one here, is actually used for comments in bash scripting. So unlike other programming languages that you have to use 2 slashes or you have to use a slash and an asterisk, in bash you actually use the octothorpe or the hash symbol or the pound sign. Most people call it that. So now that you understand that, now this line has to be present in all your scripts. Okay, the reason is because the system has to know what shell to use to run your script and to understand that this is what this system will use to run the script. So alright, so the next thing that you have to do, usually this is all the line you need to start your script. Okay, so you put the line and then you start writing the body of your script. But the problem is, just like other programming languages, there are a rule of thumb. Okay, you don't just write a script without putting things like comments in it, without telling someone or the user that is going to read your script what the script does, or who created the script, at what time, what the title and description, or if your script have options, which one you're going to use. Alright, so it's always a good practice. You can always include them in comments. So you can include things like the title. Let's say the title is my first script. Let's say want to put the date in it. So the date could be, let me put date. So let's say the script was created today. So I'm just going to put 11. Let's say 11/2012. All right. So the author who created the script, yes, I created my script, so you will be the creator of your script. Alright, so if the script is going to have multiple versions in the future, then this will be probably version 1.0. You can put a description. Okay, so a description or purpose, a script that displays hello world. So let's say this is our hello world script, right? Alright, so let's see the script. Does it have any options? I can omit this, but if you want options, you can put options here, or usage. Some people use the usage option to tell others how to run the script. So if you feel your script requires a special way of running it than the conventional one, then of course you can always include that here. Alright, so the next thing that you begin with is you start with the begin and then the end. Now this is really not useful, not needed. This doesn't do anything, it's just a comment, and this doesn't do anything. So unlike other programming languages that this has to maybe be a syntax, this is not a syntax. Okay, so you can omit this one right here and doesn't matter, but this is just so it tells the person that it's reading our script where we're starting and where we're ending, and of course just makes your script looks nice. Alright, so let's run the legendary hello world. Obviously every program will have a way of showing you this, every programming language. So this is our first script. You can see I'm just typing the echo hello world here, and this is exactly what I can type on my command prompt to give me the output, but this time around we're putting it in a script. So go ahead and familiarize yourself with this. Always make sure you don't forget this. I'm going to go ahead and save the file, Control X and Y, then I'll press enter since I'm using nano. If I do an ls-l here, I'm gonna have a problem here because I can't write the script. Okay, so even though we edited the wrong scripts and we created a different script, so let me go ahead and remove script1.sh. You can see here, remove regular empty file. I'll just say yes. So I'm just left alone with this file. Alright, so here you can see that the script is highlighted in green, and this is by design of the shell prompt I'm using here because it just colors everything and gives you visual feedback. So if I use the -l option here, what I'm interested in is here looking at the permissions bit. This file cannot be run, so if I try to run this script.sh, I'm going to get a permission denied error like we did, and if you guess right, the exit status is going to be 126. Okay, so this is one of the errors we looked at. So what this means is we need to make the script executable, and to make the script executable we actually have to add to the list of permissions the executable permissions or bits. So this is okay. This is usually what you have to do. So you use the change mode command and you append an executable permissions to the script. So in this case script.sh. So if you're wondering what I just did to complete this, so let's say I just use a tab key. So you use a tab key to auto-complete list of files and commands in the path. So I press enter, and now if I do an ls-l, you can see now there's X in the output. And to run the script, I will make sure I'm inside the directory that the script lives in. So in this case, my script lives in the home CMP319 directory, and in there I have a script.sh. So to run the file, I simply just type // then script.sh, and I press enter. So you can see that our script has run, and this is the output from the hello world command. Alright, so congratulations, you've created the first shell script, bash shell script, and over the course of the upcoming videos we'll just quickly run through some concept and steps and some basic scripts. And the idea is after running through all these videos, then you try to tackle the projects at the end of the course material you have for this course. So yes, that's it, and this will be a good time to end this video, and then we'll come again and continue from where we stop. And if you have any questions, as usual, always send me an email. You can contact me, or you can go to the page for this course material and you can get additional information, or you can post a comment if you like. So from me, it's bye bye, and hope you enjoy it. So have a nice day.